Now we take a look into the example for the high frequency response. The value for all capacitance are given here. CW in, CW out, CBC, CBE, and CCE. Even you see in this circuit, there is no CBE, CBC, CCE, and even CW in and CW out. CW out there is no capacitor in this figure. But you must know that every time you want to find the high frequency response, then this value will be included. Okay, so you know where is the CBC, CBE, and CCE. So CBC is here, B and C. CBE is here from B to E. And CCE here, CCE. Okay, then CW in is here, CW in. Then we have CW out. Okay, so for this question, A determine RE, B determine AV mid, C determine FH in and FH out, D determine the cut-off frequency, which is FH, E sketch the asymptotes, and high frequency response, which is the actual response. Okay, actual response using Bode plot. For A, we calculate A, okay, because this is the voltage divider, so I use approximate method. For this method, I need to check this condition. Okay, so beta RE now is 144 kilo ohms and 10 times R2 is 100K. So this conditions is satisfied, which is beta RE greater than 10 times R2. So I can use approximate method in this voltage divider circuit, which means the VB now is equal to VTH. So I can calculate VB directly from the VTH. So when I calculate the VB here, which is the VTH, I get 1.795 volt for the VB. Then, after we get VB, so VB is here. From the equation VBE, then I get the VE. So VE become VB minus VBE. Then I get 1.095 volt. Then when I get VE, so I can get IE. So IE equal to VE over RE, and the current is 0.913 milliampere. And finally, calculate the RE. So we get 28.48 ohms. Then determine the AV mid. So in the AV mid, you calculate the AV. We might gain. First, derive the equation for the voltage divider. So for this circuit, remember that this circuit has RL, which means the gain that we get now is loaded gain. So I calculate the RL into the equation. So V out equal to negative IC multiply with RC parallel with RL. This is the Z out. Okay. And the IC is equal to beta IB. This is the equation 1. And equation 2, V in equal to IB beta RE. Now, when I calculate for the V out over V in. So I get negative RC parallel with RL divided by RA. And insert all values. So I get the mid-band gain is negative 72.91. Now we determine the FH in. So remember that this is the equation for the FH in. So the RTH, we calculate here RTH, we get RS parallel R1, R2 and parallel beta RE. Then this is the answer, 614.56 ohm. Okay, and then for the C in here, the C in is the CW in, CBE, CBC. Okay, this is the CMI. So please be careful with the value for the CBE, CBC. So I hope you are not do a simple mistakes by replacing this number with others capacitor. So for this formula, it must CW in plus CBE plus CBC. Okay, this is the CF multiply with 1 minus AV mid. So this is loaded gain. Okay, and then okay, finally we get C in 931.92 picofarad. Okay, insert all value for in the FH in, and then we get finally 277.89 kilohertz. And now we calculate for the FH out. So for the FH out, the RTH out is RC parallel with RL, and we get 2.08 kilo ohm. For the capacitance is C out equal to CW out, CCE, and plus with CM in. This is CM in, CM out, sorry. The CM out equal to CBC multiply with 1 minus 1 over AV. So we get C out is 28 picofarad. Then insert all value in the FH out, we get 2.73 megahertz. Okay. Now determine the cutoff frequency. We get two values from FH in and FH out. For the whole system, the high frequency response will be the smallest value of from both high frequency values. So now the smallest is 277.89 kilohertz. This is the FH in. So this is the cutoff frequency now.